So this is 7.6a, elementary algebra, and the name of this section is proportions. Phew! Boy, after those last few lessons, this section on proportions should be a breath of, well, fresh air if you're mathematically inclined. A proportion is basically two ratios, and if you remember, a ratio is basically just a fraction. So a proportion is comparing those two fractions. So notice those are the same fractions. One is just reduced and the other one is not. But that's a proportion. And we have two parts of proportion. Well, I guess I should say two different ways to label these. First term, second term, third term, fourth term. And then we have what are called the means. Means means these two sets of numbers, the bottom and top, and then the extremes. So extremes are these that I did in yellow, and the whites are means. Okay, so you multiply the means, you multiply the extremes, and if those are equal, then the ratios are equal. So in this, if we multiply the extremes and we multiply the means, we get 12 equals 12. So that means the ratio is equal. Now, what makes this such a good way to solve problems is that whenever we have x, and it doesn't matter where x is, in order for those two to be equal, we multiply those two, and we multiply those two. And we just solve for x. So x is actually, this number here actually goes right there. And 21/6 obviously reduces down to 7/2. So that's really the number that you would want. And that's pretty much all there is to proportions. Now obviously there's some that get a little bit more challenging, like this. But again, you just multiply the diagonals. Do that, and then we multiply those. So we get x times x plus 1 equals 3 times 2. So x squared plus 1x equals 6. And then when you have something like that, especially with an exponent of 2, you set it equal to 0. We'll just take the 1 off of there. Subtract 6 from both sides, and you get that. Then you make your little parentheses, and we get x plus 3, x minus 2. So therefore, x is negative 3 and 2. Okay? So there's two solutions. So if we went back to our original problem here, and we put negative 3 in here, and here, they would be equal. So let's try that. Let's see, negative 3 plus 1 over 2 equals 3 over negative 3. So this is negative 2 over 2 equals 3 over negative 3. And you're like, what the heck? Those aren't equal. Well, any number over itself is 1. Any number over itself is 1. So yes, that does work. All right, so let's try the same thing with 2. 2 plus 1 over 2 equals 3 over 2. So this is 3 over 2 equals 3 over 2. And that also works. So, two answers to that problem. So remember, when you have an exponent of 2, you're going to have two answers. So this really works well if you're trying to figure out maybe how much money you're going to make. So let's say, for instance, somebody says they'll pay you $30 for working 2 hours. Well, maybe they say, I think I'd like you to work 40 hours. And you're like, well, how much money am I going to make? Well, how much money would you make in 40 hours? If you make 30 and 2, that ratio needs to be the same as however much you'd make in 40. So again, you multiply across. So, 30 times 40, divide by 2, divide by 2. So you'd make $600 then in 40 hours if you made $30 in 2 hours. That's $15 an hour. So if you took $15 an hour times 40, you'd end up with $600. So that's kind of a way to check. But anyway, this whole proportion thing is kind of nice. I use it an awful lot when I'm figuring out different things, you know, when I'm kind of sitting around just doing math in my spare time. And I'm kidding. All right, so application. A manufacturer knows that during a production run, 8 out of every 100 parts are going to be defective. So that's the ratio. 8 of every 100 are going to be junk. If the machine produces 1,450 parts, whoops, might help if I wrote 1,450, right? Do you ever catch your hand just doing weird things and you write numbers that you didn't even mean to? And they want to know how many defective parts they're going to have. So if we know that 8 out of every 100 are bad, and you run 1,450 of these, and they want to know how many are bad. Well, we don't know. But we do know it's this ratio. So we put those together and we multiply across like this. Okay, so then you've got 1,450 times 8 equals 100x. Divide by 100. Divide by 100. Cross that goop out. And we have 116. That's how many parts out of our 1,450 are going to be bad. About 8%. Okay? So let's look at example number 4. Erase what I've got here. All right, a woman drives her car 270 miles in 6 hours. Okay? If she continues at the same rate or the same speed, how far will she get in 10 hours? Now notice, my units are the same on the bottom. That's how I know where to put my third number here. Do I put it on the top or bottom? Well, hours down here, hours down here. Okay? So then I'm trying to figure this out. So what they're going to do in these problems, these story problems, they're going to give you 3 pieces. So if you just drew a line, equal, line, and just put numbers up here, 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 and here, and you're going to be given 3 numbers, and the 4th one is going to be your x. So it's pretty easy as far as figuring these things out, or at least setting the equation up. So now I have 6x equals 2700. Divide by 6, divide by 6, x equals 450 miles. See, we didn't even have to know how fast she was going. We just needed to know how long it was going to take her to go a certain speed. All right, takes us to example number 5. And a baseball player gets, all right, let's do the little thing like, whoops, I don't want a times sign, I want an equal sign. Player gets 8 hits in the first 18 games. If he continues at the same rate, how many hits will he get in 45 games? So 45 goes down here with the other games. And we're looking at how many hits he gets in 45 games. So you multiply 8 times 45, 360 equals 18. X, divide by 18, divide by 18, cross those out, x equals 20. Okay? So ratios really are not too bad. In fact, I did this whole lecture in less than 10 minutes. So let's look at, I'm assuming that you're going to be able to do 1 through 20, but let's just at least look at 20. I won't do the whole thing, but let's just look at it. Okay, so you just do diagonals. Diagonals. Okay, and then you just distribute. And then just move things around till you can find x. Okay, now the story problems, everybody thinks the story problems are so much harder, but they're really not too bad, because all you have to do for these story problems is draw a line, equal line. And any one of these are going to work. Let's look at 24. I mean, just off the top of my head, I haven't even looked at this one yet, so it's cold. A solution contains 15 milliliters of HCl and 42 milliliters of water. If another solution is to have the same concentration of HCl and water, but is to contain 140 milliliters of water, how much HCl must it contain? Okay, very, very freaking confusing. But we have our line there. What's it say? 15 milliliters, 42 milliliters. What's our next number? 140. 140 what? 140 water, so we know it goes on the bottom. And we're looking for that. There you go. So you're just going to multiply. Equals 140 times 15, which I have no idea what that is. So anyway, shouldn't give you too much trouble doing these if you just follow this rule. You know, line, equal line. Put in the three numbers they gave you in the right place and solve for x. Okay, so that's it for lesson 7.6.